Hey students, this is lesson 612, the Pythagorean theorem. And we are going to learn how to use Pythagorean theorem to find problems, to solve problems related to right triangles. I'm going to skip here to page 12. And here's the theorem. I'll just describe it real quick. We'll spend a little more time in class going over that. But basically what was discovered is that if you have a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So basically what we're saying here is this: if you were to square this leg here, which is A, and B is another leg, C, the longest side is always called the hypotenuse. You need to know that. But if you square that, so if you find the area of this square right here, and if you find the area of this square right here, if you add those two squares together, they will equal the area of this square right here. So, and if we use algebra to show that, then the area of this square is a squared, because both these sides are a. Both these sides are b, so the area of this square would be b squared. Both these sides are c, so the area of this square is c squared. And that's where we get this formula, a squared plus b squared equals c squared. Now, to show you how that would work, here's on problem one. It's giving you an example of how you can use it to find the length of one side of this triangle, which is the hypotenuse right here, C. And basically what we're saying is that the area of this square, which is a square tile, would be 6 times 6, which is 36. The area of this square right here would also be 6 times 6, which is 36. And the area of this square right here on the hypotenuse would be the same as what I would get if I added these two together. So, and this is C. So this is C. So I can say right here that C squared is equal to 36 plus 36, which is 72. And that comes from the Pythagorean theorem. Remember, a squared plus b squared is equal to c squared. All right? And now to find this, remember, we could just take the square root of both sides. And the square root of c squared is c. And the square root of 72, I could simplify that this way. And square root of 36 is 6, so I could say that this is exactly 6 times the square root of 2. Or if I want to use my calculator, I could just approximate that, find the square root of 72, and I would find that that's about 8.5. All right? So what we want to do is find the length of a hypotenuse of a right triangle with legs of length 9 and 12. And this next page, you will see a problem that leads you through it. I'm going to let you go ahead and do that. Pause now, and then I'll fill in the answers just so you can check back and see if you did it right. All right, how'd you do on that one? Should have found that the hypotenuse is 15 centimeters long. Okay, we can also use Pythagorean's theorem to find the length of a leg, kind of using the formula but working backwards here. And here's an example. So we know that one leg is 5, we know the hypotenuse is 13, and we know Pythagorean's theorem, a squared plus b squared equals c squared. So we can substitute 5 for a, that's this side, that's one of the legs, and 13 for c, which is the hypotenuse. And then if we simplify that, we get 25 plus b squared equals 169. So b squared is 144. And then, and that comes from, we just are working backwards. We took 169 minus 25 to get that. And then b is equal to 12 because we just find the square root of 144. So the side length is 12. Okay? So I'm going to let you try that here. See if you can find the length of the triangle at right. Okay? And actually the work is here for that. You just write in a justification each step. So where are these numbers coming from? All All right, we have another property here. It's called the converse of Pythagorean's theorem. Converse pretty much means opposite. And so the opposite of the Pythagorean's theorem is also true, that if you have a triangle with side lengths A, B, and C, and A squared plus B squared equals C squared, then the triangle will be a right triangle with hypotenuse length C. So all you have to do to check is see if A squared plus B squared equals C squared of 3 sides. And the longest side, the C, will always be the biggest number in the set. So, so what we need to do is figure this out. For this one is 12 squared plus 16 squared equals 20 squared. So we're basically trying to see if that's true. 12 squared is 144. 16 squared is 256. 20 squared is 400. And if we add 144 plus 256, we get 400. So since 400 is equal to 400, a triangle with side lengths 12, 16, and 20 is a right triangle because 12 squared plus 16 squared is equal to 20 squared. How about 9, 11, and 14? Will that make a triangle? That's a right triangle. So we're going to try this 9 squared plus 11 squared. See if it's equal to 14 squared. That's 81, 121, and 14 squared is 196. And 81 plus 121 is 202. And that is definitely not equal to 196. So we're going to say a triangle with side lengths 9, 11, and 14 is not a right triangle because 9 squared plus 11 squared is not equal to 14 squared. So we can use that to identify right triangles here. And all we need to do is do the Pythagorean theorem with these 3 numbers. So we're going to do 5 squared plus 8 squared and see if it's equal to 10 squared. That's 25 plus 64. And 10 squared is 100. And 25 plus 64 is 89. And since 89 is not equal to 100, we're going to say this is not a right triangle. So let's just put no for that one. And I'll do one more with you. Let's do this 9 squared. This one here. We'll do 9 squared plus 40 squared and see if it's equal to 41 squared. That's 81 plus 1600. And is that, let's see, 41 squared. I'm needing a calculator for that one. So 41 squared is 1,681. And if I add these two together, I also get 1,681. And so those are equal. So we're going to say, yes, that's a right triangle. And here's my proof right here. All right, you try the next 2. See what you get on C and D. All right, so you should have noticed that C and D, those side lengths will not make right triangles either. And here's the work to show that. All right. Here's another problem for you to do. Go ahead and do this problem, and you can check back with the answers. All right, so that's the end of the lesson here. The rest of it we're going to do in class. You can go ahead and do this lesson check to see if you understand. And we'll talk about that when you get to class next time we meet.